Hi guys, welcome to the first video on an introduction to titrations. In this question we're going to take a look at the 2012 higher level paper. Again, as with all of them, we can do so much of this without attempting a calculation, so we can do 1, 2, 3, 4 parts of this particular question. We can get a total of 32 marks in this question, which equates to 64% without attempting a calculation. The first calculation is asking us to calculate the exact mass of anhydrous sodium carbonate required to prepare this solution. Now, in order for us to calculate that, we need to look back on the question, and we see from the question that we have a 0.05 molar solution of this. Now, what does that 0.05 mean? That means we have 0.05 moles per litre. In this question, I don't have a litre, I only have 5,000. So the first thing I'm going to do is to figure out how much I have per 500 centimetres cubed. And the easiest way to do that is to divide by 2. So 0.05 divided by 2 leaves us with an answer of 0.025. Again, that's in moles, and we want to go to grams. The easiest way for me to do that is to multiply by the relative molecular mass. We have 2 NAs, which is 23 by 2. We have 1 carbon, which is 12 by 1, and we have 3 oxygens, which is 16 by 3. And when you add all of that up, we get 106 grams. So our final step is to multiply by 106, and that gives me an answer of 2.65 grams per 500 centimetres cubed. The final part of this question is asking us to calculate the moles per litre and grams per litre of the hydrochloric acid solution. Now, we don't know anything about the hydrochloric acid solution, so what we do need to calculate now is our ratio. And we need to see in our ratio that we have, for every 2 moles of hydrochloric acid, we have 1 mole of sodium carbonate. The first thing we're going to need to do is figure out how much of the sodium carbonate we actually used. So 0.05, because that was the concentration, divided by 1,000, and we only use that in 25 centimetres cubed portions. When we do that, we get an answer of 0.00125 moles per 25 centimetres cubed. Now, from our ratio, we can see that we have a 2:1 ratio. So we have double the amount of hydrochloric acid than we do carbonate. So the first thing I'm going to do is take my 0.00125 and I'm going to multiply that by 2. And that tells me that I have used 0.0025 moles of acid. Now, in this question, if I flick back, it tells me my average titration figure is 20.8. So that tells me I have 0.0025 moles in 20.8 centimetres cubed. So I don't want it in 20.8 centimetres cubed, I want it in moles per litre. So I will take my 0.0025, divide that by 20.8 and multiply it by 1,000. And when I do that, I get an answer of 0.12 moles per litre. The final step in this question is to calculate grams per litre. So to calculate grams, I'm going to multiply by the relative molecular mass. So of HCl, we have 1 hydrogen, which is equal to 1. Chlorine is always our tricky one. We take it as 35.5, so we're going to be multiplying by 36.5. And when we do that, we get our final answer of 4.38 grams per litre.